Hey guys, today's video is about frequent item set mining. In the previous videos, we've discussed why it's a strong rule, but we haven't talked about how to find a strong rule. If you just do exhaustive search, the computation time would be slow, and the system might even crash because the operator is overloaded. In fact, there is a process that can help us find these strong association rules efficiently. However, this is not the most efficient method. It's just a simple trick to optimize the computation process. So, the first step is to find all the frequent item sets. Frequent means the support of the item set is larger than minimum support threshold. The second step is to use the frequent item sets to generate strong association rules. Since we check the support in the first step, we just need to make sure the confidence of the rule is larger than minimum confidence threshold. In this video, I only talk about how to find all frequent item sets, and I will make a separate video to introduce how to generate strong association rules. Let's get started. Apriori algorithm is a popular algorithm in finding frequent item sets because it's easy for computer and is interpretable for human. The foundation of Apriori algorithm is a priori property. It basically says that all non-empty subsets of a frequent item set are also frequent. It's intuitive, right? If the database has 4 transactions containing both A and B, then there are at least 4 transactions containing A because A is just a subset of the union of A and B. For example, we have this database. The item set A contains banana and orange, and the minimum support threshold is 0.5. Then, A is a frequent item set since its support is 3/4, which is larger than minimum support threshold. A has 2 subsets, banana alone and orange alone. If you look at our database, you will find the subset also has support 3/4, which means they are also frequent subsets. Just think about the logic behind it and you will find this property totally reasonable. Next, the consequence of this property is that if an item set is not frequent, none of its supersets can be frequent. For instance, if B is not frequent, then A is also not frequent because A is a superset of B. To explain, if A is a frequent item set, then B must also be frequent because A contains all the items in B. What I'm saying now is in fact the a priori property, so they are just simple logic, not difficult math. Let's look at an example. We have 4 transactions T1, T2, T3, and T4. We want to find all the frequent item sets given the minimum support threshold 0.5. We start with one item set, which is the item set containing only one item. So we have 5 item sets, A, B, C, D, and E. I put their corresponding supports below them. You can check the numbers by yourself. Then, we cross out the non-frequent item sets because from the a priori algorithm, we know that if an item set is not frequent, none of its supersets can be frequent. In other words, we don't have to consider the item set containing C anymore because they can't be frequent. Following this, we move on to the 2 item sets. These are basically the combination of the frequent 1 item sets. So there is no C involved because the item set C is not frequent. Again, we calculate the support for each item set, and we cross out the non-frequent item sets. Only A, B, and B, E are frequent item sets because their support are equal to the minimum support threshold. Therefore, we only have one candidate for 3 item sets, which is A, B, E. The support of A, B, E is 0.25 because only T3 contains all of A, B, and E. However, this item set is not frequent because 0.25 is smaller than minimum support threshold, 0.5. In fact, even if ABE is a frequent item set, we can stop our calculation here because we don't have enough items left to make a bigger item set. To recap, we start with one item set and we cross up the non-frequent item sets. Then, we combine the one item set to form two item sets. Again, we ignore the non-frequent item set. And there is only one possible three item set. We only have to check whether it's frequent or not. In this case, it's not frequent because its support is smaller than minimum support threshold. So, that's how we find all the frequent item sets efficiently. Another way to think about Apriori algorithm is to plot a tree diagram. We start with the lowest branches, which are one item sets. Then we remove the branch that doesn't fit the requirement. Then we grow the tree based on the frequent item sets. Again, we remove the branches that are not frequent. Further, we move upward to a higher level, which contains three item sets. We find this item set is not frequent, so the tree dynamic ends. When there is only one branch left, the tree ends no matter the branch is frequent or not. So that's the idea of Apriori algorithm. Although Python can do this in just a few command lines, it's better for a user to understand the logic behind it. And there are a lot of advanced algorithms you can choose. Apriori is just a basic one. Thank you for watching my video and I hope you enjoyed it.